So the 5.0 solution, first thing I'd say is look at it. Just look at the outline, look at the thickness, the depth, the overall construction, and compare it to other machines in its class. And if you look closely, you'll start to see everything is fatter, squarer, stiffer. It's also, which helps, very, very good looking. If you look closely at the steel frame, the entire machine build is based on a very advanced way of producing a CNC frame where the entire frame is put on an aerospace machine, and the aerospace machine machines the tolerance surfaces for the running gear. So you end up with a really precise steel frame as the core basis. And then if you look at the aluminium upstands, we're 65 mil of 6 series aluminium connecting the crossbeam up into the bridge, which is a common position where machines fall down. They have poor connection between the cross running train and the actual bridge system. If you look at our Z-axis and all of our rail systems, it's all 20 mil profiled rails. We have the 20 mil ball screw, and the entire machine itself runs on closed loop AC servo. So the servo is constantly checking the position of all the axes. So you don't have any of this step loss issue that commonly you see in the forums around other platforms where axes start to actually stall and lose position. It's full industrial closed loop AC servo. We've affiliated directly with Techno in Italy, so we have a very long standing relationship in Stony CNC with Techno. They've been a phenomenally reliable spindle. So in addition to this, our spindle system, it's got ceramic bearings, it's running in the factory, it's balanced, and it's running a second time. It's the grinding process that actually makes the collet cone is very precise. This gives us a very good level of run out, which is important for tolerance parts. It is a very long-standing field service reputation. So our oldest spindle is 12 years old, and the reliability has been phenomenal. And the spindle is an aspect of the machine you have to be careful of, because it's the one that is under the most stress, and it's the one that's the last line of defense for tolerance. So any eccentricities, bearing play, vibration, forget it, machine's out of tolerance. So we only ever use the best, and we don't compromise at all. And overall, the machine rigidity, so the stiffness between the actual spindle where the cutting tool is located, relative to the workpiece, is extremely stiff. So you can machine faster, you can machine deeper, you can use larger cutters, you can drive more spindle power, and you can achieve a much tighter tolerance in a much smaller time frame. So you make a guitar body in 4 times less than you do on a machine that's, I don't know, half the price. Or you can machine to a much higher level of tolerance in 20-25 mil aluminium, and your edge finish when you're machining in the non-ferrous realm is completely incomparable to a competitor's machine because of the rigidity and the design principles, no compromise, and the closed loop servo making sure everything is tight and toleranced.